Okay, so 15. Okay, suppose you have a function which depends on x and y. So let's say f is a function, w here is a function depending on x and y. Okay, function depend x and y here. And then x and y can be expressed in terms of r and theta because x, of course, can be written as r cosine theta. This is actually polar coordinate there. Y is expressed as r sine theta. Right? This is the usual polar coordinate. Okay. So the first part of the question is asked you to show this. Show two equations, dw, dr. And go to partial differentiation with respect to x first, then cosine theta, then plus partial differentiation with respect to y, and sine theta. Okay, first thing I should show this, and then the second thing I should show is 1 over r dw d theta. Okay, show that this is equal to minus f of x of sine theta plus f of y. Okay, partial differentiation by the y and cosine theta. So this is the first step. Okay, how do you do that? This is again using the chain rule for partial differentiation, right? W depends on x and y, and then x and y depend on r and theta. So eventually, W will depend on r and theta, right? So you can talk about what is differentiation of W by respect to r. Okay, differentiation of W by r. So first, W depends on x and y first, so you can do partial differentiation with respect to x first, then partial differentiation of x by respect to r. Okay, and then plus partial differentiation of f with respect to y, W is x and y here, then multiplied by partial differentiation of y with respect to r. Okay, so the first term, of course, is fx here. Okay, what is differentiation of x with respect to r? That means that you differentiate x with respect to r. What is this one? You keep theta constant now. Okay, theta constant, take out differentiate r. Then you get cosine theta. So this is actually cosine theta here. Okay, this is fy. Differentiate y by respect to r. So you keep theta constant with respect to r. You can sine theta. Differentiate 1 over r. Differentiate r now. Of course, to the sine theta. So this one very fast. So you got the first term already. Okay, how to secure it? You just differentiate using the chain rule. So using this formula. Okay, let's try the next one. So W can also depend on theta now. So I can actually find dW d theta now. Using the chain rule is W depend on x and y, so you can partial differentiation of f with respect to x first, then partial differentiation x with respect to theta, then plus partial differentiation of f with respect to y, then partial differentiation of y with respect to theta. So this is fx here. So how to find partial differentiation of x vector theta here? So x equal to r cosine theta. So dx d theta now, keep r constant. Okay, keep r constant, you get differentiate cosine theta now, you get minus r sine theta. Right? So this is actually minus r sine theta. And then you can do the same thing for cosine, because ry now, y equal to r sine theta. So partial differentiation we are set to theta now. You keep r constant, differentiate this sine theta. Differentiate sine theta, of course, you get cosine theta. Okay, this df dy, which is partial differentiation relative to y. Okay, so this will give you r cosine theta. Okay, so this is partial differentiation of the df relative to theta. So now divide both sides by r now. So 1 over r partial w partial to theta, you get minus fx sin theta plus fy cosine theta. So this is the second here, which is here now, right? Same. This is how you show part A. So part A is actually alright. Part A, right? How to show part A? Using the actually chain rule for partial derivative. Okay, so now I'm going to move on to part B now. Part B. Insert another page here. Part B. Solve the equation from part A. Express fx, okay, fx, fy in terms of partial derivative relative to r and partial derivative relative to theta. So basically, r so you solve fx and fy now. Okay, so what does it mean? So this is the equation we have in part A here. dw dr is fx, okay, cosine theta plus fy sin theta. This is one equation. And then we have another equation, 1 over r dw d theta is actually minus fx sin theta plus fy cosine theta. Okay, solve this equation. Okay, this is simultaneous equation. How do you solve this equation? Okay, there are many ways to solve this equation. You can say take the first equation times something, okay? So for example, you can take the first equation times cosine theta, the second equation times sine theta, and subtract. I think you will get one of the fx, okay? You can do the same thing for multiplication, okay? First equation times sine, second equation times also cosine, okay, then you get something you want. This is one possibility. I think I just leave it to you how to solve this equation. Well, let me help you to recall Cramer's rule first. You heard about Cramer's rule? Okay, Cramer's rule is, I think if you look at Cramer's rule, is actually one of the best, one of the easiest to solve this equation. Yeah. So let me help you to recall what is Cramer's rule first. So I'll just talk about Cramer's rule first in a while. I'm going to go to Google and search Cramer's rule here. So let me show you the show the search first. So stop sharing. I want to share the Google. Okay, Google now. Cramer's rule. Okay, just in case I don't want to write too much there. Cramer's rule. Okay, Cramer's rule. Okay, you can see the website. Cramer's rule. You want to solve an equation. What you do is you want to find what is x, right? This is the equation where you get x, y, z there. You want to find out what is x. You replace 211. Okay, you can replace 211, 2x, 1x, 1x, 211 replace by 300. Okay, so to replace 211 by 300, and then you take a determinant dx over d. Okay, dx over d, you take the dx here over d, then you get the answer for x. So how do you find answer for y? To find answer for y, there's a 1y minus 1y, 2y, right? Replace d, and replace by 300, and divide by d again. Okay, you can find out. This is a simple Cramer's rule, something you learn in linear algebra. Okay, so let me go back to the problem again to help you to remember that whatever you learn, you're going to use a lot today, what you learned last time. Okay, so I go back to the go back to this. So what are the number you do now? So first of all, what is d first? Okay, what is the d first? Okay, supplies d is equal to, okay, d is the determinant of cosine theta, sine theta, minus sine theta, cosine theta. Okay, d is actually this small number together. Okay, the unknown is your fx and fy. Okay, the unknown is your fx and fy, and d is actually this small number put together determinant. So what is the determinant now? So this determinant is actually cosine square minus sine square, right? Okay, AD, you do the determinant, you should do this way, AD minus this one, right? So that means that you have determinant is equal to cosine square plus sine square, which is 1. Okay, cosine square plus sine square is 1 now. Now let me I want to find the I want to find the fx now. So fx is equal to what now? It's equal to according to Cramer's rule is actually dx over d. So what is dx here? The first column of d replace. The first column of b is replaced by dw dr 1 over r dw d theta. First column is cosine theta minus sine theta, right? Replace. Second column keep, right? Same. And d we know is 1. So again, you use the arrow, okay, positive and negative, right? So what is this equal to? You can find that this is equal to dw dr cosine theta minus 1 over r dw d theta sine theta. Okay, so this is how we get the fx here. Okay, this is how fx is done in this way. You can use grammar rule, very straightforward here. Okay, just replace the first column of d by the right hand side. The number you want to replace. Same thing here. I want to find fy now. Okay, fy is now the second column replaced now. Second column replaced by dw dr and 1 over r. Okay, so I think I need somebody have information there. Let me pay attention to this later on. So dw d theta over 1. Okay, let me go back and see if anybody got the message. Tell me. Okay, because people got message, right? So let's see what is it now. Anybody got a message here? Okay, nobody got a message for me. Okay, so I thought somebody got a message for me, so I need to explain. So from here, then you get, okay, what is this thing now? Is actually 1 over r dw d theta cosine theta, then minus, okay, minus come plus already, right? So minus, so this is plus, minus, then minus come plus already. So this become plus now, okay, plus dw dr sine theta. Okay, so you check that this is really the answer given to you in question 15 part A and B, right? Okay, question 15 part A and B, this is really the answer. How you find the fx, fy from here? You just replace by using a Cramer's rule. Okay, replace get this one. So this is what we call the dy, dy over what? Again, change the same column. So this is how you get the Cramer's rule. I use Cramer's rule to solve so that I know this is not a mess there. So this question 15b, right? Question 15b, and just now question 15a, right? Question 15a. Okay, 15a is over already. Okay, 15a. Okay, so 15a and 15b. Next, I want to find 15c. All right, 15c. So I insert again. Okay, insert again 15c. Sorry. Okay, asked to show this fx square, fy square. Okay, show that this is actually partial differentiation of respect to r square plus 1 over r square, okay, partial differentiation with respect to theta square, right? So how do you show this? So you make use of the fx and fy first. So fx you square first, let's see what we get. So fx according to the formula is, the answer we got earlier, is cosine theta, then dw dr, okay, minus sine theta over r, and then dw d theta. Then you square it. Okay, so you square it become cosine square now. Cosine square. Then partial ratio to r, you square it. Then minus 2 cosine theta sine theta over r, partial differentiation by w with respect to r, and partial differentiation w with respect to theta. And using this one, a minus b square a square minus 2ab plus b square, right? So this is actually last one is sine square theta over r square and square dw d theta square. Okay, so this is, I got this, then I copy the Fy again. According to Fy, in my answer, Fy is sine theta, okay, dw dr, and then plus cosine theta over r, then dw d theta. I want to square it. So when you square it, you can, okay, I don't need this one, okay, maybe it's just a bit closer, so like this one. So this is sine square dw dr square. This plus now 2 sine theta cosine theta over r, and then dw dr dw d theta, then finally cosine square theta over r square dw d theta square. So when you add them up, ready, add them up, you get, what is it now? You find out a log cancellation. First thing is these two cancel, enough. Then you also have what? Okay, you also have sine square plus cosine square is 1, right? So they all are common factor. So this thing add together is straight away tell you that this is actually dw dr square. Okay, this can give you this one. And then over here, same, sine square plus cosine square is 1, right? So we get 1 over r square and dw d theta square. Okay, that's how we get this. So this is how you answer question 15C, right? The whole question of using, starting from chain rule, and then digress a little bit, use something you know in AM2, and then find the answer. Okay, so now it's 3:30 already. I make sure that I have finished everything by 5. Okay, because some of you have to go for test. So this is a bit of tutorial question. Okay, then the next part which I want you to pay attention now is really the hard topic now. This will take a bit long now.